Alright, today, and I start every video with the word alright, but anyway, hey, can't help it. Today we're going to be looking at what's known as a chain rule. What do you do when you've got a function in a function? And right now you're probably going, a function in a function? Yeah, that's right. I don't know another way of saying it. But let's go through the definition of what a chain rule is, then let's just do some examples so that you kind of know what to do in those situations. So a chain rule is really saying, when you've got like this, you've got two functions. This g of x is a function and f of g of x is a function. What you're going to do is, and this is the way I do it, and some people do it opposite, but I like to take the derivative of the whole function. So I take the derivative of the entire function and then multiply it by the derivative of the inside function. So I'm going to take the derivative of f g of x times it by the derivative of just the derivative of g of x. And if you're like me, you're probably still looking at this and going, what? So the best thing I know to do is let's just do a couple of examples. So I'm going to do just 4 examples here, maybe 5. So let's do this one first. This would be a very basic one. Y equals 3x plus 2 to the 5th power. Now, you could do this by just distributing this sucker, writing it out, and fooling the thing, whatever. 3x plus 2, you get 3x plus 2 plus 3x plus 2 times 3x plus 2 times 3x plus, and no thank you. Here's what it means is this. When you look at this function, I want you to do this. There's two functions here. The 3x plus 2 is a function, and then this whole big thing is a function. So I'm going to ask you something that I know you can do. What if I just said, what is the function of, what if I just said u to the 5? What is the derivative of u to the 5? So if you had something u to the 5, you would multiply times 5, u, and then subtract 1 from 5, and you're left with 4. So you know how to do this. Well, this is no harder. Take the derivative of the whole big function. In other words, what I want you to do is ignore the whole 3x plus 2 in the middle. I want you to just take a look at this overall function. So what I want you to do is, again, ignore the 3x plus 2. 3x plus 2 to the 5th. Multiply by 5. Subtract 1. You're left with 4. Take the derivative of the big function. Now multiply that by the derivative of the inside. What's the derivative of, we'll write up here, 3x plus 2. What's that derivative? Well, that would be 3, and the derivative of 2 is 0, so it'd just be times 3. So your answer, the derivative of the whole thing, times the derivative of the inside, would be multiply, be 15, 3x plus 2 to the 4th. There's our derivative. That's how easy the chain rule is. Well, let's not just do one example. Let's do several examples here. So what are we going to do if we've got, let's say, a function square root of x squared plus 1. Let's say that y equals square root of x squared plus 1. Well, first of all, let's rewrite this. Let's write x squared plus 1 to the 1/2. I don't like writing out these radicals. Now when I look at this, you can tell I've got two functions. X squared plus 1 is a function, and then this whole thing to the 1/2 power is a function. Again, ignore the inside. Pretend this was like r to the 1/2. Just take the derivative of something to the 1/2 power. Times by half times x squared plus 1. Now, subtract 1 from 1/2. And that's negative 1/2. And now times the derivative of the inside. What's the derivative of, and again, this is x squared plus 1. Take the derivative of that inside function. Well, that would be 2x plus 1, well, the 1 is a 0, so we're done. Now, this is kind of a sloppy looking answer right here. You can go ahead and tell the half and the 2 are going to cancel. And this is to a negative power, which means we need to stick it. Let's do this. Let's move this down here. X squared plus 1 to the 1/2. Let's get it. That way we got rid of that negative 1/2. And then this half of 2, that cancels. So we're just left with x. So there's our derivative. Bam. It's that simple. Here's another easy one. How about x squared plus 1 to the 3rd power? So let's take a derivative of that. Well, dy dx, going to use a different notation this time. Yes, I work at a place with 34 bells that go off a day, so my videos are full of them. Take the derivative of the whole function. So 3 times everything. 3 times x squared plus 1. Now take the 3, subtract 1, that's 2, times the derivative of the inside, which the derivative of the inside again. This is the thing. Ignore everything now but the inside. So this would be 2x plus 0. So we've got 3 times 2x. Our answer is 6x times x squared plus 1 squared. So my derivative is what you see there. Let's do one more with this chain rule. Now, I think it's in the homework, and I think it causes some people a little bit of problem. I think I see one more in the homework that might give somebody a problem. We'll work it. Let's do this one, though. Let's throw in a radical and put a 3 out in front of it. Let's get a cube root here. X squared minus 1 square. When you first look at this, you might be thinking, oh, this is crazy. No, think about it. If you know how to do a square, I want you to look at this. What if I told you to take a square root of x squared? Well, you know that's x. Have you ever thought about why it's x, though? All you're doing, remember what a square root is. It's a half power. All you're saying is x squared to the half power, which is 2 over 2, which is, that's the reason why the square root of x is just x. We just don't ever think about this 1/2 and all this kind of stuff. Here, look at this. We've got x squared minus 1 square, and then this is the way I want to rewrite it. I want to rewrite this to the 3rd power. Well, this is the exact same thing. X squared minus 1 to the 2/3. That's all we've got to do. So we just combine that. Now all we got to do is, now we can do our derivative. Times by 2/3. Subtract 1 from 2/3. Well, let's see, that would be negative 1/3. Times the derivative of the inside, which is 2x. And now we can clean this up a little. Let's see, we'd have 2 times 2, 4x over 3. I'm going to move that negative 1/3 term to the bottom. X squared minus 1 to the 1/3. Let's do the little dy dx notation here. Keep changing up the stuff. Anyway, that's a basic chain rule. I'm going to look through this homework assignment here. I don't really see anything that I think is going to give you any problems. Matter of fact, the only one that even looks halfway like something to notice. Let's take a look at this one. we've got t squared. I'm just going to do it right here in the center of my paper. T squared minus t to the negative 2 power. Well, take your derivative. Do the power rule. You've got this t squared minus t to the negative 2 power times by negative 2. Negative 2 times t squared minus t. Subtract 1 from negative 2, so that's negative 3. Times the derivative of the inside, which would be 2t minus 1. And we could clean this up a little bit and have negative 4t plus 2 over t squared minus t to the third. No joke. I work in a school with, I think, 34 bells. But anyway, sorry, apologize for that in these videos. But hey, people watching this probably go here, so it's all cool. So y prime, there's my derivative. Ooh, let's take the second derivative. You're probably not ready for that yet. Anyway, thank you for watching. I hope this helps at least with my homework for my students. But anyway, thanks and later.